When most people think about Yellowstone, they picture the end of the world. The popular nightmare is a massive supervolcano hidden under the park, eventually waking up to blanket the earth in ash and plunge us into a catastrophic global winter. That fear relies heavily on a persistent myth about the volcano's timeline. The story goes that Yellowstone experiences a giant eruption roughly every 600,000 years. And since the last major caldera-forming event was 631,000 years ago, the math seems to point to us being dangerously overdue for the next one. But geological systems do not operate on a predictable train schedule. According to the U.S. Geological Survey, taking the average interval between a handful of past eruptions doesn't give us a crystal ball for the future. The concept of an overdue eruption is a mathematical fiction. We know this because of what we see in this cross-section of the shallow rhyolite magma chamber beneath the park. Rhyolite is a highly viscous, silica-rich volcanic rock, but this chamber isn't a churning ocean of liquid lava. In reality, that reservoir is between 85 to 95% solid rock. There likely isn't even enough molten material down there to feed a massive eruption. While the public keeps looking down into the deep crust for an apocalyptic explosion, they are completely missing the highly active, volatile threat bubbling just inches below their feet. To find that real threat, researchers recently deployed machine learning to re-examine 15 years of historical seismic data from the park. They wanted to see exactly what human seismologists might have missed. This map illustrates 86,000 hidden earthquakes AI uncovered within the park, a tenfold increase in recorded seismic activity over the last 15 years. These swarms of small tremors congregate tightly. Beneath the caldera, they migrate along rough, immature fault structures in complex, repeating patterns. This invisible, subterranean violence is happening right under the boardwalks where millions of tourists casually stroll every single year, admiring the thermal pools without feeling a thing. The machine learning analysis reveals Yellowstone as a hyperactive, chaotic machine, driven by massive volumes of shifting, boiling fluids that are constantly fracturing the rock. All of that shallow crustal activity comes down to water. Every year, massive amounts of rain and snowmelt seep down through the porous volcanic rock, creeping toward the extreme heat of the geothermal system below. To track how those underground fluids are moving, scientists rely on a specialized network of GPS stations scattered across the park. These stations are incredibly advanced. By locking onto multiple navigation satellite constellations and correcting for tiny atmospheric distortions and clock synchronization errors, they can measure ground movements down to a fraction of an inch. What they reveal is that the ground at Yellowstone is literally breathing. This topographical grid of Norris Geyser Basin demonstrates how entire areas rise and fall by over 10 centimeters over a period of months as massive volumes of underground water pool and drain. When you combine that surface deformation data with the AI earthquake catalog, a clear picture emerges. Every single one of those 86,000 micro-quakes is a direct symptom of a highly pressurized fluid network struggling to vent. The trap is set when that cold surface water sinks, gets superheated by the geothermal system deep below, and naturally tries to rise back to the surface. But often its path is blocked by a caprock. A caprock is a layer of dense, hydrothermally altered clay that acts like an impermeable seal over the rising fluids. Because the water is trapped beneath this seal, it cannot boil, even as its temperature climbs well past 212 degrees Fahrenheit. The extreme physical pressure forces it to stay in a volatile liquid state. This is where those 86,000 earthquake swarms become incredibly dangerous. The constant grinding microquakes continuously fracture the rock, actively weakening the structural integrity of the caprock holding back that superheated water. It creates a geological pressure cooker. The pressurized water is the gunpowder, and any one of those tiny, unpredictable earthquake swarms could be the trigger. All it takes is a single seismic event from a swarm to suddenly crack the caprock wide open. When that seal breaks, the underground pressure drops instantly. That pressure drop triggers an immediate phase change. Without the immense weight holding it down, the trapped superheated liquid instantly flashes into steam. Because water vapor takes up vastly more space than liquid water, the expansion is exceptionally violent. The steam rapidly accelerates upward, completely shattering the surrounding rock to escape. This is known as a hydrothermal explosion. A massive column of boiling water, steam, mud, and jagged rock fragments erupts upward without a second of warning, and the scale of these blasts is terrifying. The resulting explosions have carved out craters up to 2 kilometers wide, launching heavy debris up to 2.5 miles away. These are not theoretical anomalies. Large-scale hydrothermal explosions occur in Yellowstone on average every 700 years, completely dwarfing the size and power of any typical geyser eruption. Look at this image. This is the Norris Geyser Basin, one of the most popular areas in the park. Many of the massive explosion craters from the past overlap directly with the exact thermal basins visitors walk through today. While geysers like Old Faithful operate on relatively predictable cycles, hydrothermal explosions do not. They are dictated entirely by those random, chaotic seismic swarms, meaning they strike with zero warning. That is why the new AI and GPS tracking is so critical. Identifying those 86,000 hidden earthquakes is the first necessary step in mapping exactly where these pressurized traps are forming before they have a chance to fail. If we want to understand the true danger of Yellowstone, we have to stop waiting for a mythical supervolcano to end the world. The real threat requires us to listen to the chaotic, invisible volcanic heartbeat pounding just beneath our feet.